Okay, unexpected part 4. My hard drive ran out of space. Right. Okay, well, why are we practicing these? Let's try it. Point B, translate to Q, rotate BC onto QR. So we took B to Q, BC to QR, and we reflected. Justify whether this will always be true based on this criterion. There is only one set of angles that bring three lengths together to make a triangle. So, for instance, if this is locked, I can't make this side any smaller or bigger. And the next two are also locked. Think of them as lengths that are, we can swing them around. The angle's not locked. This can swing around all day. But there's only one spot where this other one, which is also locked, it can swing around, but they'll only meet up in one spot. Everywhere else, the tip doesn't come together. The end of that vertex won't come together. Like this could be over here, which would be allowed, but then it's not. Size can't change, so it can't make this side shorter. This is side, 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 so the three sides can't change length. You could swing this out and have this arm longer, but now it's not even going to reach this other side. So there's only one way for three sides to make a triangle. So if you go out and measure three sides of a triangle and three sides of another triangle, and all the three sides match, there's a pair for each one, then those triangles are congruent. Based on these experiments and your justifications, what criteria or conditions seem to guarantee that two triangles will be congruent? Well, if we have two angles and the side in between them, that's the first one we looked at, then that works. If we have two sides and the angle in between them, that works. If we have all three sides paired up between two triangles. Remember, this is all about two triangles. Oh, I chose a bad combination. There we go. Now, those are not drawn correctly, but they are marked to communicate that those triangles are actually congruent. Because I've marked three sides, and side, side, side means that two triangles have to be congruent. We just learned that. So this is why the marks came about. When people draw lines by hand, it's impossible to get them correct. Now with computers, geometry is slowly shifting away from marks and to just accurate things. But we still have to communicate, and we communicate through marks. Your friend wants to add AAS to your list, even though you haven't experimented with this particular case. This seems familiar. Oh, we did SSA, which doesn't work, but we haven't done angle, angle, S. Interesting. So that's when we know two angles, but this side could be whatever, but this side would be locked in. So this side could shrink or grow. This doesn't seem to hit. If this hits here, let's make this side a little longer. If we move this angle, slide this angle in, like this angle's locked, right? And so is this one, because we have angle, angle. Oh, I'm not even on the screen. That's annoying. Okay, here's a scenario where this side is question mark, and this angle's locked, angle, angle, and on one side. This side has to be this long. But notice that if this side is this long, this angle will hit the end of this line. It has to hit the end because this side cannot change. If we slide this angle in, because this side's not locked, but then it won't hit it in the right spot. So it kind of implies that there's only one length on this side that will work. And in fact, AAS does work. For a couple of different reasons. For the reason we just explored, and also, turns out, we'll cover this more later, triangles always equal 180 degrees. So if we knew two angles, we actually could figure out the last angle, and then it just turns, angle, angle, side can turn into angle, side, angle. But because of this phenomenon, we will get this next one. Your friend also wants to add hypotenuse leg to your list, even though you haven't experimented with right triangles at all, and you know that SSA doesn't work. That's when you have two sides and an angle. But your friend wants the hypotenuse and a leg, but the only angle you know is the 90, so this is side-side angle. But in this specific case, for a 90-degree triangle, for a right triangle, would it work? Well, remember how we explored a lot how if we could swing, let's see, what do we know? This length can't change, and this length can't change, and this angle's locked. So we could swing this arm around to this side, I guess turn the triangle around, but it's going to be a mirror image of the same triangle. So hypotenuse leg is a special case where SSA does work. But because it's a special case, we give it its own name. So watch out for right triangles. If you see a right triangle, then as long as you know the hypotenuse and one of the legs, it will work. All right. Go ahead and do the ready for more if you're ahead in class. It's rather involved. Lots of symbols. See if you can decode that. It'll be good for you. And we are done. We've covered all this. Let's go through it one more time. Angle, side, angle. Side, angle, side. Side, side, side. This one we haven't talked a lot about, but AAS will work. And hypotenuse leg. Not guarantee. The naughty one. And also AAA does not guarantee. And finally, we are done. 4 parts in. See you in the homework.